All right, so we have 4 feet of wire, and we want to use it to form a square and a circle. So we want to know how much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area. This one has a little bit of a twist in it, so we'll get to that. But we want to start, I'm going to start with a picture just so we can see what's going on. Our goal is to have a square and a circle. And our primary, the thing that we are trying to maximize, is area. So area of the square, I'm just going to call these x. So it's x squared plus the area of the circle. We're just going to call that r. So area of circle is pi r squared. So that's what we want to maximize. That's our primary equation. Our secondary equation is how much wire we have. So our secondary equation, we only have 4 feet of wire. So the perimeter of the square is 4x plus the perimeter of the circle, or the circumference, is 2 pi r, and those are 4. So we need to solve that for one of the variables. It does not matter which one we solve for. I'm going to solve for r, I think. I don't know. Doesn't really matter. So we have 2 pi r equals 4 minus 4x. And then I'm going to divide everything by 2 pi. So I get 2 over pi minus 2x over pi. I think that's right. Okay. And now I'm going to plug that in over here into my area formula. So I have 2 over pi minus 2x over pi. And I'm going to go ahead and FOIL that out before I attempt to take the derivative. I think that'll be easier. So that's going to give me 4 over pi squared minus 4x over pi squared minus, I think that'll be minus 8x over pi squared plus 4x squared over pi squared. So that's going to give me x squared plus 4 over pi minus 8x over pi plus 4x squared over pi. That's probably good enough. Okay, so now we want to take the derivative of that. I'm going to switch colors so I can see a little bit better. So the derivative is 2x. The derivative of 4 over pi, that's just a constant, minus 8 over pi plus 8 over pi x. And we want to set that equal to 0. So when we do that, we're going to get 2x plus 8 over pi x equals 8 over pi. And then we'll factor out an x. And then we divide and we get 8 over pi divided by 2 plus 8 over pi. And when we do that in our calculator, we get 0.56. Now, I told you there was a little bit of a weird thing going on with this one, is we want to know the domain. We haven't really focused on the domain a whole lot, but let's go back and think about this. So our feasible domain for this problem is, we want to know how much we're using. Let's focus on x. So we could spend nothing on the square. Okay, so our x is somewhere between 0, and the most that we could spend on this, remember our total wire is only 4 feet. So if we spend it all on that, the dimensions of the square are 1. So our domain has to be between 0 and 1, which you can see that 0.56 falls in that. But remember, we're trying to maximize the area, and we could have maximums at one of our endpoints. So what we're going to do is go back to our area formula, this thing, just our original area formula, and plug in 0. Actually, we want to go to the one without the r. Go back to this one. Okay. We want to plug in 0. We want to plug in 0.56. And we want to plug in 1. Okay. Because we know 0.56 might be the maximum, but one of the endpoints might be as well. So when we do that, when we come back to this and plug in for x, I'm going to skip showing you how to do that in the calculator. We get 1.273, 0.56, and 1. And notice that this is actually the maximum area. So even though we got an answer of 0.56, that's not the actual answer. What we really want is we want x to be 0. And if x is 0, that means that we're spending none of this wire on the square, okay? So our solution should be all wire is used to make a circle. And that's going to be the most effective use of those 4 feet of wire to enclose the maximum area.